Okay, so this is going to be chapter 2.x sub 1a, limits 1. The reason why this naming convention is all wonky is because it's not exactly mentioned in detail in the book, but I think it's very important. So here we are. So if anytime you guys see notes where the chapter's like 2.x or whatever, that's because I have to insert some more details in. Okay, so let's let's revisit where we left off in the last video, right? The question was Um, what kind of intervals are best for approximating slopes? Right? And so I'll give you guys a slightly different function this time, just so we can kind of see it more visually, all right? So let's say that this is oops, our function, right? And it looks a little bit like, I don't know, like that, right? And you want to find the slope at this point. Let's call this x sub 0, right? Or x naught for short, right? X naught. If you were to use an interval, right, um, to approximate this, you might say, oh, um, you can go here. Let's call this x sub 0, so whatever our number is, plus 5, right? And then what you can do is you could just f of x sub 0 plus 5 minus f of x sub 0 all over this minus this, right? We go back to the original form we had. You could say f of x sub 0 plus 5 minus f of x sub 0 all over x sub 0 plus 5 minus x sub 0, right? If you were to simplify this, you might get something that looks like minus f of x sub 0 all over 5, right? It's important to note that you cannot break this into this minus this, okay? Don't do that because you have to run it through the function first, right? Okay. This is fine. It's fine, right? Now, what if I said, okay, I want a different x sub 0. Let's say I wanted, oh, what the heck? Let's say I wanted that, right? And then we approximate for, let's say, from here, right? Let's call this x sub 0 plus 8, right? If you approximate the slope going this way, right? What you'll find is that this slope is positive, right? It's going up, rise over run. But if you look at the slope here, right? It's actually negative. And so you probably don't want an interval that's too far, right? Or else, this is decreasing, this is increasing, that would do bad things. Okay. So what if we tried something different, right? What if we said, oopsies. What if I said, let's call this sum x sub 0 plus k1, right? Just some number, right? Would it be better to choose this? Oh, and the distance, of course, is k1, right? Would it be better to choose this as a distance? Or would it be better to choose maybe here, x sub 0 plus k sub 2, where, k2 has to be smaller than k1 because this point is closer to this point. I'm gonna give you guys a second to think about that and then we'll chat. Okay. So if we say that this is better at the smaller distance value, right? What if I asked you about x sub 0 plus k3? Is it going to be better to choose k3 as a distance, k2 as a distance, or k1 as a distance? Since we already established this will take you here, you might be inclined to want that, right? And then what if I said, oh, we can choose something even smaller? What if I said x sub 0 plus k sub 4? What about a distance of k5? What about k6 or 7, 8, right? What's better? A k that's bigger or one that is smaller? Ultimately, right? I would hope you said smaller because the closer you get, the more accurate your estimation is, right? And if k is getting smaller, what number is it heading towards? I'll give you a second to think about it. For me, I would say that k is heading towards 0 because your distance from your point A to your point B is getting smaller. Okay. And so congratulations. Excuse me. You have discovered the idea of limits. Let's do a definition. Definition. This is going to be definition 21. Okay. Limit of a function. I said one dimension. I should have cut that out. It's okay. Limit of a function is going to be written like this. Lim x approaches c of f of x means the limit as x approaches c, which is some number of the function f of x. Okay. An important note is the output follows where y is going relative to x, not where x is going, because we already know that x is going to c. Okay. Okay. It'll be easy. It's just input output. So let's do some examples. Okay. We'll do one together and then I'll have a handful for you to do on your own. Let's say one, the limit as x approaches 5 of 3x squared, right? If you were to graph it, which you can on Desmos if you'd like, you'll find that this is equal to 3 times 5 squared, which is 75. Easy. Cool. So what I'm going to have you do is I'm going to have you consider some of the following ideas as well. The limit as x approaches infinity, trust and believe, of 1 over x. And note, one does not simply plug in infinity into a function. One does not simply treat infinity as a number. Okay, I'm going to put a pause on this recording and we will lose. So, funny story, you see. I did all this and the video was never recorded, it was just audio. So what I'm going to do instead is I'm going to go through this, but like, I'm just going to show you guys instead of writing because it takes a lot of time. Okay, so I'm going to actually have you guys, this is actually the solution. So I'm going to have you guys work it out on your own. I'll insert a clip of. So if you're seeing this, this is because you worked it out. So the first one, as I had mentioned, is pretty easy, right? Just plug it in. You get 75. You look at this, you go, oh yeah, you follow it going that way and going that way. Definitely 75, right? What about this? You can't just treat infinity as like a number, right? Because it's not. And so you have to do it slightly differently. How is it behaving? Oh, I have this section recorded. Okay. Anyway, so you're gonna do all these problems out, and these are the solutions. Okay. As x approaches infinity, let's use powers of 10. 1 over 10 is small. 1 over 100 is even smaller. 1 over 1,000, even smaller. And so the limit as x approaches infinity of 1 over x is going to be 0. But what about the limit as x approaches 0 of 1 over x? Ah, it's undefined, isn't it? We'll get back to that one. And what about this piecewise function here? On the left-hand side, it behaves like x squared, and on the right-hand side, it behaves like x plus 1. So when you actually draft it out, right, blue side is heading towards 1, pink side is heading towards 0. They're not going the same place, right? So what we're going to do is we're going to introduce something else. I'm going to call them one-sided limits, okay? The left-hand limit follows the function as x approaches your number, c, from the left, that little negative sign, okay? So in this case, you're going to follow from the left, right there, okay? Similarly, you're going to have the limit as x approaches c of f of x from the right. And in this case, you're going to follow it from the blue side, okay? When you work that out, you're going to find different answers, and that's okay. So here are my big picture expectations when it comes to solutions, okay? So function tends to infinity, the limit doesn't exist because infinity is not a number, right? And so, of course, right, if they both go towards positive infinity, make note of that. They both go towards positive, and both sides go towards positive infinity, but infinity is not a number, so limit doesn't exist. If they go in different directions, make note of that. Limit still doesn't exist, okay? Um, on the other hand, right, if the limit are two different numbers, right, limit doesn't exist. The overall limit doesn't exist because the left hand does not equal the right hand side, okay? And lastly, if the limit of the left is equal to the limit from the right, which is, if they're equal, then the overall limit, if you see here, there's no symbol, the overall limit is equal to whatever this number is. Okay, here is our example number 1. So the limit from the left follows the pink side, limit from the right follows the blue side. I'm going to have you guys just kind of stare at it and convince yourselves it's true. Okay, here's another example. If you notice here, right, the function's defined at 1, but that's okay. Actually, it's not defined at 2 over here, and that is still okay, because the left-hand side is still going towards the right-hand side, so everything's okay. Same here, left-hand side, right-hand side, doesn't really matter what's happening here, right? You can get abducted by aliens and dropped off somewhere else, and that's perfectly fine, okay? And finally, you have this. Left-hand side, it's actually defined. The right-hand side, it's not defined. That's okay, because they don't even match up anyway, so the limit does not exist. And so, limits at infinity, x approaches infinity, what happens to y? You might remember this from pre-calc, horizontal asymptotes. Yeah, that's just baby's intro to limits at positive and negative infinity. If you have vertical asymptotes, your limit will head towards positive or negative infinity. Okay. Which means the limit doesn't exist. And so the question I'm going to leave you off at is what happens for this function right here, x plus 1, x plus 2 divided by x plus 1 as x approaches negative 1. Try the left-hand side and try the right-hand side and just see what happens. Okay? All right.